Hello. In this video, I will discuss an error that you might occasionally encounter when using Interface Equilibrator, which is this error shown here in the background. This error can trigger when you try to select a solid surface mesh as constraint for a fluid interface mesh boundary. I will now show you why it triggers and how to prevent it. For example, let's say we want to simulate a droplet wetting a cylindrical solid surface. So, we first load a mesh to represent the solid surface. I load the mesh from an external file, where I previously saved this cylindrical mesh. Let's now add the mesh to represent the fluid interface. I select the mesh from the built-in meshes, and then I select the sessile droplet mesh, since this is the topology we want to simulate. We now need to select the solid surface as constraint for the droplets boundary, and then we are ready to launch the equilibration. However, when we click Set Constraint, we get the error message that I showed you before. Operation failed. Boundary facets are on both sides of the solid surface. As a result, the solid surface mesh was not selected as constraint for the fluid interface mesh boundary. However, the vertexes of the fluid interface mesh boundary were displaced successfully on the solid surface mesh. So, why did this error trigger? The reason is that the boundary facets of the fluid interface mesh are located on both sides of the solid surface mesh. For example, these edges going from a boundary vertex to an internal vertex are attached to the external side of the cylinder. However, the edge going from this internal vertex to this boundary vertex, instead, is attached to the internal side of the cylinder. This is not allowed. To start an equilibration, all the edges going from an internal vertex to a boundary vertex need to be located on the same side of the solid surface mesh where that boundary is. In this case, the external side of the cylinder, and also this edge is attached to internal side of the cylinder. So, we need to edit the initial shape of the fluid interface mesh in a way that all such edges end up attached to the external side of the cylinder. Let me first save this configuration for later convenience. Let's now launch the tool to edit the fluid interface mesh by translating some of its vertexes. This mesh edge is attached to the wrong side of the cylinder, so we select its internal vertex. Then, we translate this vertex in the x direction by an opportune displacement, so that the edge becomes attached to the external side of the cylinder. We now repeat the same procedure, also for the other mesh edge that was attached to the internal side of the cylinder. That is this edge. Hey. Again, by displacing the edge's internal vertex opportunely, we can rotate the edge such that it becomes attached to the external side of the cylinder. All mesh edges going from a boundary vertex to an internal vertex should now be attached to the external side of the cylinder. So, we should now be able to select the solid surface mesh as constraint for the fluid interface boundary. And indeed, this time it worked. We can now launch the equilibration to calculate the equilibrium shape of the droplet wetting the cylinder for the selected Young's contact angle. In other situations where such an error occurs, it might be more difficult to edit the mesh shape like we did this time. However, you can also use different strategies to create a valid initial shape for the fluid interface mesh. For example, I have now reloaded the previous configuration. As we saw before, for this fluid interface mesh shape, I cannot set the cylinder as constraint for the fluid interface boundary. instead of editing the mesh shape like we did before. I can simply try to displace the mesh opportunely in a different position, and then try to reselect the cylinder as constraint for its boundary. This time it worked, because after the boundary vertexes are moved to the cylinder's surface, all the edges going from a boundary vertex to an internal vertex are attached to the external side of the cylinder. So we can launch the equilibration. Of course, this strategy is not convenient when you want to define a precise volume for the droplet. But in that case, you can follow the approach of growing a very small droplet to the desired volume, like I have already shown you in a previous tutorial video. I now remove this fluid interface mesh, so I can quickly show you this approach again. First, I load a sessile droplet mesh. However, I select a very small volume for it, 0.001. Then, I select the cylinder as constraint for its boundary. Finally, in the equilibration settings, I select to vary the droplet volume during the equilibration by the desired quantity, say 0.999. So, when launching the equilibration, we will calculate the equilibrium shape of a droplet with volume equal to exactly 1. Thank you for having followed this video. For more information and for other tutorial videos about Interface Equilibrator, please visit our website.